we brought the seismograph to you, well, to my house, and from my house to you by videotape. And so we're going to take a few minutes to illustrate how a seismograph works. This is a totally cool machine. This is called the MEQ 800, the micro earthquake recorder, invented in the late 1960s and was kind of a revolution in seismological observation, because this little self-contained unit is like a completely self-contained seismograph that can operate for up to 48 hours, and in a remote area you could set up an instrument, record earthquakes, bring them back to the laboratory to study. So I'm going to use the MEQ to illustrate the basic components of a seismograph. So attached to the recording instrument we have here a kind of demonstration version of the recording part of the instrument, or the sensing part of the instrument, known as a seismometer. So if you can see here, the seismometer consists of a few key parts. It's got a rigid frame that we would, place on the ground. Attached to the frame is a spring, and attached to the spring is a weight, so that when the earth moves up and down, the weight stays in the same place. But there's a magical thing. If you can zoom in, it's not really so magical, but a kind of miracle of technology here. That weight actually is not just an ordinary weight, it's a magnet. And inside this tube is the magnet going up and down, and on the outside of the tube is copper wire. So who knows what happens when you take a magnet and move it inside a coil of copper wire. This, my friends, is a generator. This machine turns mechanical motion of the ground into electricity that comes out of through this cable and in to the recording part of the seismograph. So now here's kind of the miracle of this machine. This is a rotating drum, and when the ground moves up and down on the seismometer, the electrical motion is used to power this pen motor, which moves the pen back and forth. And a cool thing of this recorder is an ancient piece of technology. It's a waxy piece of paper with a layer of soot from a dark sooty flame that it coats the paper, and when the ground moves up and down, the pen records the ground motion by moving back and forth and tracing a fine trace on the paper. And at the end of the day, we cover it in shellac and save a kind of permanent record of the Earth's motion in this piece of paper we refer to as the seismogram. Now, of course, this seismometer is not the type of instrument we would use out in the field. This is a kind of demonstration instrument. What we would use is something like this. This one is called a Mark Products L4C seismometer, and if you can come a little closer, perhaps you can hear this sound. This seismometer has a spring in it, just like this demonstration seismometer, and it has a tightly wound coil that picks up very tiny motions of the ground and turns them into signals. So we're going to replace this toy seismometer with a real seismometer, and we're going to plug it in here into the MEQ, and now you'll see that the ground is moving all the time. So I don't know if you can see from where you are, but when I move up and down just the tiniest amount, the pen moves back and forth.
Get Tuck to drop his ball.
Okay,
Maybe that'll
Tuck,
help.
ready? Okay, come here, Tuck. Watch the pen. It just hit the seismometer. Okay, so we just created a tiny earthquake there that is going to be recorded on this seismogram. There's one more important element of this machine that is a critical part of every seismograph. And if you can zoom in, let's see if I can see this here. On this little part of the machine is a super precise clock. so precise that it keeps track of time within a few milliseconds over the course of an entire day. So why does a seismograph have to have a very precise clock in it? Well, it is that timing that we use to get the exact time when the seismic waves arrive at our seismic instrument here. You saw a bunch of controls on the top of the instrument. We can increase the sensitivity of the instrument. So now I'm increasing the sensitivity. So just the tiniest motion here is picked up in a large record of the ground's motion. We can in fact record motions so small that they are a fraction of a micron, and this instrument might increase the amplitude of the signal by a factor of several 100,000. So if we were doing a seismic experiment, we would set this up to record. We would grab the cover of the MEQ. We would carefully close it up here. And this is a completely weatherproof unit that would operate for a course of 24 or 48 hours. At the end of the day, we'd come back to the instrument and we would collect the recording of seismic data here. One thing I didn't mention before that's a critical part of this drum is that as it's recording, it's slowly rotating. So the drum is rotating, and as it's rotating, the pen is gradually sliding down this knurled knob here over the course of a day, so it creates kind of a spiral record of the day's seismic events. At the end of the day, we open it up after we've shellacked it and preserved it. We have a complete seismogram recording the entire day's seismic events. So using an instrument like this and dozens of others around the area, we can precisely locate the epicentral location, the hypocentral depth, and from the amplitude we can measure the magnitude of the earthquake. So this is your quick 5-cent tour of the seismograph here at the Hamburger home, and hope someday you guys get to see the real IU seismograph recorded at the geology building. Thanks for watching.